Hello everyone, I hope you're fine. We'll be looking at probability today, right? 11. So now what is probability? Probability is the likelihood that a given event will occur or happen. And you have to know that probability it is expressed as a number between 0 and 1. Probability has to be between 0 and 1. It cannot be greater than 1. It cannot be less than 0. So 0%, 50%, maybe then I have half, and then what? 100%. Okay? That's what we gotta know about probability. So now, let's go to the probability equation. So this is the probability maybe of A. This is the probability of what? Event A, just for example. But now I wanna tell you what probability sebenza kanjani. So a probability it is like this probability maybe of A, it is equals to the number of favorable outcomes. So it can be number of favorable outcomes. Favorable outcomes, let me just say outcomes here, right? Outcomes over what? The number of total outcomes. So then I can say total outcome. You see, this is the total. It is very important. That's what I mean, Masity total. So for example, one, a die is rolled. Not a dice, a die is rolled. Example, a die is rolled. Not a die is that thing that you rolled. It has 1, 2, and what 6. So now, if a die is rolled, what is the probability that the die lands on the number 4? I'm to know that the die has number 1 to 6. So the answer is that there is only 1 4 on the die. So which is the what? The favorable outcome. Right? And then on the die there are 6 numbers. So it means these are what? Total number of possible outcomes. So it means the pi, the probability of the die landing on 4, it is equals to 1 because there's only 4 on the die, number 4 on the die, over what? 6. These are the total size there, you see. But if it happens that maybe but it representing decimal form, this will be 0.17. If maybe they say percentage, you do what? 16.7%. You see, that is it. That is what you're talking about when you say probability now. So now let's go to the probability law. The law of probability. That's the introduction about probability. So now you're in the probability law. So there are a few concepts that I want you to know. This is just introduction. So now I told you what if they say probability of A. This is what? The probability of event A occurring. Sharping it, we are now fine. Now this one now P, and then you'll have your A here and something like this now. So this means that the event of A not occurring. So this thing now, that small one there, it basically means it is not event of A, it is not occurring. Okay, it is also called the complement of A, but you just have to know that this thing, it means that not occurring. Okay, so now there are some few things that I want you to know. So maybe you'll have 2 events or 2 probability. So now you'll have some ways whereby there is what? Probability of A and B, right? So when they are saying probability of A and B, you are not going to represent them This is just the same as what? P of A. And it then there's this thing and then B. That thing that is looking like N, it basically means what it is what? And it is also known as the what? Intersection. Okay, and then it basically means with the probability of A and B occurring is that thing. So there is intersection between probability of A and B. So you have now this one of A or B. So this one is what? P of A, but this one is now like this. This and this are the same thing, just that they are represented in different ways. But what does this thing mean? This one means what? Union. Okay, it basically means union. It is just or. Okay, just like that. Now let's go to the mutually exclusive events. I hope you understood this thing. And it is what? Like this. Or wait, yes, or it is what? Like this. That's what it means there. There's nothing that you'll have to be busy being worried about. Just know. Now let's go to the additional rule and mutually exclusive events. So now let's go to the what? Additional. So these are the formula that you are gonna use to help you. So let's start with this one. Eh? So now let's just say you have something like this. Probability of A or B, ne? It is equals to the probability of A plus. So basically, or it means what you are doing what? You are adding. No, but don't go there. Just know what it is plus what? Probability of what? B. I don't want to confuse you for now. You'll understand it when you are now going there to the trig diagrams. Then now this is what? Minus probability of what? A and B. You see? Or it can be represented like this. Probability of A union B is equals to probability of A plus probability of B minus probability of A intersecting B. It can be written like this or this. You are gonna just choose for yourself, but just the same thing. And it can be like this now. It can be like this if you don't write it like that. You can say probability of A and ne? Is it fine now? Okay, let me not confuse you for now. Now I wanna show you this one on a different method, because there's no what you call probability of A and that's no, there's no such. I made a mistake by telling you that. No, now let's go to the mutually exclusive. Sorry guys. So let's go to the mutually exclusive events. So what are mutually exclusive events? It is like if two events are mutually exclusive events, it means that they cannot occur at the same time. They cannot occur at the same time. Okay, for example, if a trial is tossing off a dice and event A is obtaining at 6 while event B is obtaining 2, it is impossible to obtain event A and B together. Like you are rolling a die or a dice. Okay, so you can't see you're gonna get 6 and 2 at the same time, because these are two different events. Okay, now basically the formula for mutually exclusive events is basically means with probability of what? A intersecting B, it is equals to 0. So it basically like you have something like this. This is A, this is B. They are not intersecting. When they are intersecting, it is like this. But this one, it is what? Not intersecting. Okay, those are mutually exclusive events. Okay, so now let's go to the next section, independent events. So now, when we are talking about the independent events now, it's only gonna include what? That word and. Okay, so independent events. So the two events are said to be independent if the outcome of one event does not affect the probability of another event occurring. Okay, so like for example, if the outcome of one event changes the probability that another event occurs, the events are said to be dependent. But now, for now, you must not worry about what dependent. Now, when they are basically thinking about independent events, I just explained right now, most. But the main thing that you just have to know, it is the formula only. So now it is also called the product rule. So this one, it is basically probability of A intersecting B is equals to probability of A times probability of B. So if this one it is 0.5 and then this one it is maybe 0.2, it means 0.5 times 0.2 must give you what? 1.0 there. You understand, most? If like Lana you have 1.0, when you multiply these two, they must give you 1.0 at the same time. But if they are not giving you the very same answer, it means they are not independent and stuff. So now let's go to the complementary events. I still have a space there, so now I can go to my complementary events. So complementary events. So when the two complementary events, it means there are two conditions there. So this one it basically means probability of A plus probability of B, it is equals to 1. So there are two conditions. Let me write the first one. Probability of A plus probability of B, it is equals to 1. Okay, so now at the same time, you will have to know that there's another one like this. The probability of not A, the one that I showed you, can be written as 1 minus the probability of A. See? Like check. Let's say I want to write I said probability of not A. Not A there, it is what? Probability of B. So for me to write probability of B, it did what? 1 minus probability of A. This A went to the other side, but now this is not the probability of A. It is not A. You see, this is equals to. You see, that's how it is. It is just working like that. The event has to be mutually exclusive. I don't want to stress you all. I just want us to do what? The examples nicely, the introduction nicely. Then you're gonna go to the examples after, because that's what you have to know, guys. And then now I think we can just do one question and then you'll now revise, and yeah, let me check something for you. So for example now, so now let's do the first one and then we'll do the second one and then we'll call it the. Now they are saying probability of given probability of A is equals to 0.5, probability of B is equals to 0.2, and the events are mutually exclusive. It means the intersection of A and B is equals to 0. But now what is the first question saying? Calculate the probability of not A. So now probability of not A, it is equals to 1 minus probability of A. I just told you now. So it means we did 1 minus 0.5, which will be 0.5 there. We are done. You see, simple like that. You say 1 minus that, simple, and then probability of A or B. But now remember, you are given that the events are mutually exclusive. For this one, I can say probability of A intersecting B is equals to 0. Already I know that. But let's go back to the original rule. What did I say? I said the formula is probability of A or B is equals to what? Probability of A plus probability of B, ne? Minus probability of A intersecting B, or I can say and. It's fine. But now already I know that it is equals to 0 because I was told that they are mutually exclusive. What do I know about mutually exclusive events? They cannot occur at the same time, so it is 0 there. And I want probability of A and A or B. So what is A there? 0,5 I'm given, plus B, which is what? 0,2. So basically it means with the probability of A or B, it is equals to 0,7. Simple, ne? Okay, let's go to the last one. Probability of not B. It's the same. So lana is the same thing. 1 minus what? Probability of B, which is equals to what? 1 minus 0,2, which is equals to what? 0,8, because you were told what probability of B is what? 0,2 there. Is it fine, guys? You see how simple it is? So now let's do the last example. I hope I was not fast. Now let's go to the last example. They are saying given probability of A, it is 0,3, probability of B 0,15, probability of A and B is equals to 0,48. Now the question is saying this, wait, I made a mistake because we already made this thing. So are these events independent? Justify your answer. So what do you know about independent events? You know what the probability of A times B is equals to probability of A union B. So I was told that probability of A intersecting B it is equals to 0,48. So now let's check. From our formula, I said probability of A intersecting B must be equals to what? Probability of A times probability of B. What is my probability of A there? 0,3. What is my probability of B? 0,15. Simple means this one. So this one must be 0,045. Are these the same thing? No, it is not. So therefore, probability of A union B, it is not equal to probability of A times probability of B. So you can conclude by saying, therefore, events are not independent. We said that in the independent events, you multiply the two probabilities A and B, they will give you A intersecting B. But in the statement, I was told that A and B are equals to 0,48, meaning that when I multiply this and this, they must give me 0,48. But unfortunately, when I multiply the two, they're giving me a different number. So it means they are not independent events. Okay. So here, shit guys, I'm done. Eh? So thank you very much for your support. Don't forget to subscribe. Thank you very much. Enjoy.